Here in the architecture table, after building the model, I analyzed the architecture using the model summary. Here the input shape is 20 cross 5, meaning each sample contains 20 time steps and 5 features. And coming to the CNN layers, the first convolution 1D layer extracts 64 features and the second increases to the 128. This helps in capturing local temporal patterns effectively. And coming to the BiLSTM layers, then I use the two-dimensional BiLSTM layers. First one is 256 output and second one is 128 output. These layers capture long-term dependencies in both forward and backward directions. And then I implemented a attention mechanism. The attention layers designed importance weights two different time steps and reduce the sequence into a meaningful representation. And then the dense layers. Dense layers reduce the features step by step by a single SOC output. Total parameters. Here the total number of tunable parameters is around 4.6 lakhs. This indicates a model, a moderately complex model capable of learning detailed battery behavior. And coming to the training process, I trained the model for 30 epochs using the Adam optimizer. Initially, the loss was around 0.018 and gradually decreased during training. I used reduced learning rate plateau to automatically decrease the learning rate when validation loss stopped improving. This helps model converse more efficiently. And then I used early stopping, and the training was stopped. We can see that the training stopped at epoch 16. The best model weights were restored from epoch 1, as we can see here. And then here we can clearly see that we have got maximum absolute error as 0.0028 and root mean square error as 0.0035 and R square as minus 0.02. Here the MAE and RMSE values are very low, indicating small prediction error. However, the R square is slightly negative, which suggests that the model is not capturing variance effectively. And coming to the graphs, in this graph, the blue line represents the actual SOC values and red dashed line represents predicted values. The predicted values are almost constant compared to the actual values. And coming to the second graph, it is the graph between actual versus predicted as scatter plot. In this scatter plot, the red line represents perfect prediction. Most predictor points are clustered in a narrow range instead of following the diagonal line. This confirms that model is not generalizing well and is predicting nearly constant values. Although the error values are low, the model is not capturing dynamic variations in SOC.